Okay, so today's date is the 2nd of the February 2026. Time now is 8:06 a.m. Let's continue with ordinances. My implementation of this is my calculator on. Look at my phone here. Show my calculator. Should have my calculator. Let me do a calculator, guys. Because if I don't have a calculator, I will not start this video, but I already got my calculator, so my pen, so I'll show my calculator. I just started. So as you can see in the board today, the board, oh wait, before we start, okay. Before we started, so trident, heterogeneous, homogeneous, canicoal interpretation for disjoint keyboard, what does I say? Sense. So so you get first of all, this video is one of the most important videos I'll make on open sense. Open sense, O for Oscar, P for Papa, O for Oscar, P for Papa, E for Echo, N for November, S for Sarah, E for Echo, N for November, S for Sarah, E for Echo is basically part of the OB initiative. So you have open sense, and you have open modal. O for Oscar, P for Papa, E for November, Echo, N for November, M for Mike, O for Orange, T for Tango, O for Oscar, R for Romeo, which is open sense initiative. But it's basically two in one. But you either open sense or open model. You bring one of these categories. For now, but you can pick your poison, pick what you want to do. So you get hyper, people on the hyper spectrum of autism. People that are hyper, H for happiness, Y for Yankee, P for Papa, E for Esco, R for Romeo. Hyper, they are hypo. So just one two from a framework. Hyper and hypo. H for hyper, Y for Yankee, P for Papa, O for Orange. So you get two type of people that classify as well. Hyper people just have use dimensions of sensory information because you have to observe information around you before you can act on it. You can do something like you have to if you have to like you have to for example there's a pathway. There's a pathway. There's a pathway. Every system has every real world system with an x, y, z coordinate system has an x, y, z coordinate, up, down, left, right, and they have two axes. So they have x has forward, backwards, y has up, down.
Good morning.
I'm busy. I was
busy.
screaming.
I know.
Get out of my way. Z has.
Hi, Rach. How are you?
I'm fine.
I'm really impressed with what we've done here before.
Sorry,
It was
Rachel.
really good.
Please.
Yes.
I'm busy. You can stay there. So fine.
No, that's fine.
No.
I'm going to leave you to do that, and then I'll come back and see it.
I'm asking you. I'm talking to you.
Thanks so much.
Sorry, thank you. Hi, Rachel. Sorry about this. So you get forward, backwards. No, forward, backwards, up, down, and side to side, or left, right, or left to right, side to side. So you get those frameworks. But what I'm saying to you, Namdi, is you get this framework for up, down, two axes to one system. But the problem here is that people that seek out more input, called hypo people seek more information from the system. So this is not really touching something or something. We should find more people. They have a threshold, but I believe there's a baseline still a hypothetical. So how can I check this hypothesis from a baseline? So the baseline is basically this is really a problem. You share a baseline of information, and this baseline is basically what determines the dimension of information you categorize in. But this is a test about this. So open motor people that are open motor, just get on with it. You have to give them a gadget and they say, "Oh yes, this perfectly works for me." That's the goal. It works perfectly. It works perfectly. So the two types of people, there are people that are hyper, and they are mostly open motor, mostly likely, they're more likely motor. That means that the motor neuron takes the goal to just use it. It doesn't matter if it's gone or a new writing equipment, like a pen tablet, you have to let the person feel the pen tablet in every pathway, the shape of the pen tablet, and see whether where to go. So the hyper, and hyper people have this is seeker motivation. Hyper people just get on with it. They are sensory bound to the system. They really know how to enter the system. It's more like they already know what information to process. It's basically the hand and eye coordination for senses, hand and eye coordination for senses. Because if the senses, if you can't see, you have to heighten your sense of sight by touch or by echolocation. Instead, the goal is literally to have this framework very important in the trial model. So the trial model is basically what's the problem you can have? You have trident consensus. You have the trident rule in the constitution. T for tango, R for Romeo, I for indigo, D for delta, E for echo, N for November, T for tango. R ruling, like controlling, like command and controlling. So the term ruling refers to commanding and controlling. So but people have to do it. So the computer has to give you a way to do that thing, and it has to be a way to do it. So you get a way to do it. A way to do it. So you get open motor, and you get open motor, you get open sense. People that seek out input by senses, and you get people who just do it. Give them the computer, give them the tablet, just get on with it. So it's basically you can use your computer to respect your senses. They respect your senses, depending on how your senses are. Hyper people just have good information and have to seek less information. And hyper people, so hyper people have to have all the information ready, really good information. And so they just seek less to just get the task done. And hyper people are the opposite. So the problem of this framework is that it's just a new framework, so it's actually pre-tested, but no one has better accessibility than OB Lexus. Thank you guys. This is a thought or not. If the holographic system does not have consensus, holographic system, you're doing something that's fake. It's fake to you. So, if I have a projection of a train set, or Lego set, up to me, I can touch it, I can feel it. I don't feel it's real. I'll lose that information too. So the problem works both ways. It works both ways. The problem works both ways. So if I have a holographic train set or holographic hellos, I'm trying to graph it, it doesn't feel real. It will not like I'm just with my daughter, holographically, on a train set on the floor. Or I don't have a daughter, guys. I don't care. So on a train on the floor, it will literally make me less of a problem because the system around me the system already there that's not bound by consensus, the holographic system will work against me. So naturally, and even the system will fail itself, its own test one. So the baseline of the metric has to be hyper and hypo, a shared dimension of hyper and hypo. So like I said before, my hand is a dimension. If I use my hand, it doesn't do anything of me. It's a big dimension of me. Doesn't matter where I use my hand, my dreams. If I use my hand in my dream, and if Isaac gets to if say Isaac gets shot in his dream, and his hand, it appears in his hand, that's his hand lost. But which is going to get shot? So so you have three dimensions. You have this one bipolar. I'm tripolar. I can be alive and dead, and dead. And I can be in a super position of both. I can be alive and dead. But this is after the time, not be alive and dead. So I can be in a super position of both. This is what I am. The proof uses the lapis, which is alpha lambda, A for alpha, P for papa, I for indigo, S for Sarah, lapis. So, this is me alive and dead. That means I have two and bipolar. But if this is the mind alive and dead, and somewhere in between, or somewhere else entirely, sure of then this is how the trident goes. So this was doesn't even trident. So the trident is literally deciding whether the information is either a 0 or 1, or you are dictating your own superposition, which is a 0 and a 1, based on the probability scale of whatever action you have. So it must not fail you, but the trident here and now philosophy is basically categorization of interpretation. So we got these signifiers, which are symbolic interpreters. And the symbol has to have a meaning. The symbol, and for that need to have a system, which must be canicalized. So, for example, channel OB is on channel zero, Uche is on channel one, CH1, and SA is on CH2. I mean, OB. Okay. So basically, this is channel framework. We if OB says if OB has all so I'm gonna use the alphabet because I'm gonna use the alphabet. So we have 26 characters in this alphabet. So we have n minus one index. So we have so they all share 26 characters, 26 characters, which is the English alphabet, alphabet. But they can say different things. They can interpret the same things. So how can I get a chemical condition between A, B, and C? And which is channel zero, channel one, CH0, channel zero, which is OB's channel, CH1, which is LH channel, and CH2, which is UH channel. Because it basically works on the system of chemicality. Because if you have valid interpretation in one of them, there's no chemical. That means it's not chemical. No, you don't share the lexical. So it's basically a lexical part. It's a lexical analyzer, but it's basically passed through the symbolic expression. So what are they trying to express, and what do the intentions mean? What are the intentions? I can say I love you, I love you, I love you. That is not chemical. That's basically I love you. We don't share that. The way we share that actually is you love me, you love me. So if Obi says I love you, Uche replies, you love me, you love me, you love me. This is a question, and this is a question and a statement. So then you get the punctuation. So if you get you love me, you get I love you, and then you get what would you say? Okay, and then this goes to now Uche. Uche says I love you, you love me, and then he hears two messages, and then he says who loves who, who loves who, who loves who, or who loves who. This question is basically the last question right now. The channel is like who loves who. So this question is a question. Listen, but it's supposed to has formalized it. Mathematically, you get 3 pointers to the data, and the 2 pointers are the actual hexadecimal pointers to the data. This is actually the hexadecimal character involved, like the ASCII A to Z sequence of instruction. So A to Z is used here because A to Z is 26 characters long, and it's going to give you some expression that means something. So we just form a question here. This question is still posed for this is this is not a chemical system. This still has some ambiguity. There's a question involved. Who loves who? And this question is what people in the true current it's a trident parser. So because you get three interpretations of a expression, you have three interpretations of parser, three meanings per meaning. So if the part of the explanation is I love you, this is Gen Z, I love you, you love me, you love me, and then then the puzzle will be whatever the share. So the puzzle is what's the puzzle will be the referential ontological. The puzzle will be what is there. So the puzzle will be I maps to you, I to you to I, that. So I is you and I. There's no difference, only the channel. Right? So the channel becomes a point of its own, you say, but it holds data. And then who loves who? Who loves who will be the anchor also. So you get minus 1 pointer. So the goal is to have 3 pointers, minus one. So you get 3 pointers that hold space. Because you get zero that holds nothing. You get minus one, which holds something but nothing. So it holds the memory allocation. So it's basically if you get zero, if you get binary zero, you get epsilon. But epsilon is nothing, nothing. So to represent a one, you have to have a true value. So the holding of a true value is a negative pointer. So its memory does not be allocated here. So its memory that's been allocated, but it's not being accumulated. It's meant to be allocated, yes, for a system, but it's meant to be used. The system computes ahead of time implicitly. That's what you should work on. So for every pathway shape or form you take, there's something that happens and you don't know it's happening, but it's matters it happens. And this is what I'm saying. The thing holds memory, byte space, but it's not just wait for other things to finish running using the memory, because the programs are interdependent, they're related. So it works like this. So I'm just doing this thing now. So we gotta go to the proof now. The minus one is just like we have some space, but it's not like the same. So we get this kind of system here. So we get x y is equal to system. What should I write? The channel. Let me run down the middle. Yep, middle here. This is so I'm trying to pull on. So here, a lapis. So this is basically ontological research. So I'm gonna teach minus one on two my I, right? I'm gonna take this channel, two loves two. So you get channel zero, I love you, you love me, we should you love. Oh wait, no. So I love you, you love me. So that's wrong one. So you love me, and then channel zero. Oh, so wrong one. So channel three will not be used. So three will not be used. So this I love you, you love me, who loves, and then that's this bit. Basically the two pointers. Sorry, the two pointers. I was still writing. The two pointers, channel zero, channel one, resolve. Because I love you has you love me, and those are ontological aspects of two pointers. So you need two minus one pointers, two minus one and minus one, two minus one pointers, which are holding of space to resolve that system. So you have to hold space ahead of time because the calculations make sense. So you have to hold double the memory. So if you allocate to 26 characters, the ASCII character to the six characters, you have to allocate 26 times 26 for this whole message to resolve between channel 0 and channel 1. And that is I love you, you love me. Now, channel 2 is not being used, but channel 2 can hold negative 1 or can hold 0. Basically, you don't have to hold anything because you use two pointers. So that's my point. So I love you, you love me, who loves who? And he says who loves who? They love each other. So who channel so now channel 1, channel 3 will be OBI loves Eze. We love each other. You said because two people that work together. So the point of resolves because there are two channels and two channels only being used, and you have to get another channel to use it. So this video was basically not a complete video, but let me try to complete it. So you will get heterogeneous, homogeneous, canicality for integration, and you get the opposite motion keyboard. So you don't have to have a keyboard sequence. So the keyboard sequence is basically you have to I'm trying to have a keyboard sequence like asking. So let me just hyper. So let me just try to so you should try to roll this out. So you get hyper, you get hyper. Let me just try to yeah, so you get it. So you get keyboard sequence. So there's a pathway, the pathway you can go, and the shape you can take, and the form you can take to resolve a problem. So the I'm going to you guys to my lapis calculation framework. My lapis, alpha llama, A for papa, alpha llama, A for alpha, P for papa, I for indigo, S for Sarah. I'm going to say lapis. So you get this lapis situation from secure a disjoint keyboard system. So you get a disjoint keyboard system. What does that mean? So, the problem is basically you get a keyboard, and the keyboard is not, this is giving you the most random set of characters, A to Z, ASCII. The most random set of characters. So you can make the long, well, I argue this can be a mathematical computer. You just you can use them, they say. So you have two main problems you identify here the time and the space. So the time. So the time capsule, the time it takes for you to move your hand between QWERTY keys, because the randomly designed by humans, it's basically humans do it randomly, but these are mathematical algorithms. I'm going to extend the time, so you don't because people can wear and tear depending on how fast you type. So QWERTY is a random keyboard, where it's just standard, it's query standard, but it's not good enough between A to Z. Forget about the punctuation. Just add a space bar, so you have A to Z and a space bar. You have 27 characters. So the 7 characters and a space bar. So the space bar is presented to the 7 characters. You get 27 between two channels, three channels, OBI channel 1. So you get 27 times. So you get 27. So you get a total of 27 to the power of 3, which is 1,000, yeah, 1,000, 19,000, 19,683. So the speed was as well, but so you get. So I'm going to have you understand how well it's works, what it is doing. So what I'm trying to do is basically determine how this works mathematically. So you have a pathway, which is like the pi over 4, pi over 3, pi over 2, and pi over 1. The pathway, the shape of the structure, the shape of the cube, the pathway you take to get to objective. So you have the pathway you get to objective, the type we want to type. So this means 2 to 1 mapping, 1 to 2, 2 to 1 mapping. So you get a pathway, you get to write down the term I love you. I love you. So we're gonna use I love you. I love you because I love that term now. It's Gen Z friendly. I'm a Gen Z teacher, so I love that term. To myself anyway. I love myself. I love myself. Let me say something. I love myself. I love me. I love me. I love me. Oh, I love me. Oh yes, I love me. I love it too. So look at the message here. The message is I love me, myself, and I. So basically, it's like an implicit proof system because it's disjoint, but it's explicitly defined. So implicit proof was explicitly defined. So that's the only disjoint proof. That's the disjoint proof. It's the disjoint is explicitly proof and you decide. So you get every pathway you take, every shape you have, every shape or structure of the problem you encounter, and every pathway shape of the problem every pathway shape, every way you go, you can resolve the system. So you get trident. So every pathway you take, like you walking a path up, down, left, right, it doesn't matter. Because you get 6 axes total. No, you get 4 axes, you get side to side. But you get 4 axes, you get up, down, and you get forward, backwards, and left and right. Forward, backwards, forward, forward, backwards, left and right. Yeah, so your fingers can move forward, backwards, with the elevation. So you get forward, backwards, up and down. Oh, hello, you're here. How are you?
Fine,
Six.
you.
6 dimensions.
Do you have time to choose your meals?
No, it's yes, main please, or double portion.
Okay, so for lunch we've got beef and vegetables.
Main please, more main, but double portion.
Okay.
Thank you. I mean, extra portion. Thank you. So you have 6 axes. You get up, down. I mean, you get north, east, southwest. Good, yes. You get north. So you get north to the power of 3. Actually, so you get north times north is north, and you get east to the power of 3, east cube, and you get south cube, and you get west cube. But they represent dimensions of axis. You can have north times north is to 2 north squared. North squared is the dimension in the second realm, the second dimension, and those north can be forward, backwards. They can be defined left or right. Left or right. But you can have something that's joint. Basically action. You want to so you want so the proof basically works like this. North squared is basically north times north. And you get north east squared. So you get north east squared. Basically north to the north 5 degrees. North 45 degrees north east squared. So that's basically east north east squared or east north east squared. And you get east south squared. But they work at the polar axis. So you get north pi over 4, pi divided by 4 to the power of 3. So that's pi divided by 4, pi, pi divided by 4 to the power of 3, which is 0.48447. And you get, for north is you get times pi divided by 3 times pi times pi times pi divided by divided by oh times pi times pi. So let's use northwest scale times pi which is 1. So you get oh no so you get, let's do pi or pi over 4. Let's do pi over 4, pi divided by 4, which is pi divided by 4, northeast, southwest, northwest times. Oh, this is basically northeast. This is west, pointing. This is basically the polar, the compass pointing west. The sun is east, so east is there, west is there. Yeah. Times pi. Oh no, this what? No, this is north. Okay, pi divided by 4 is north. So this is north. Pi divided by 4 is north. And northwest would be times pi. North times pi, which is pi, times pi divided by 1, which is 2.6 2.4674. 2.4674. So basically the area is 2.4674. But the dimensions basically have the unit of 2.46740. So now we have divided by 360. Now 360 will give you the units that they share in radian, no, in degrees. So this will give you in radian. Oh, this basically so basically this angle is basically times pi. But you have to do another times pi. So you have to do pi, the angle divided by 180. So pi divided by 180 will give you radian. So I'll do divided by 180, which will give me degrees. Let's see what it gives me. Divided by 180 in radians will give me, yes. So the angle, to me to be facing, actually let me just do pi divided by 4, pi divided by 3, or pi times pi divided by 3 instead. So let me do the one like pi divided by 3 times pi will give me 3.289 um 2.38 3.2.38 2.38 2.38 2.38 3 no 3.28 is pi. It's basically pi pi over 1 or pi over 1 times pi divided by 3, and that will give me 3.2. If I divide it by 180, I'll be dividing by the radian. I'm just going to after times by and after do the angle in radian. So this angle divided 3.28966 will give me an angle in radian. But I don't want radian, I want degrees. So degrees will be so 2 degrees. So this basically not given times 180 pi times. So let me do 3.28 degrees is Fahrenheit, no Celsius temperature. Area, angle, radian, degrees, radian. So the angle's in radian. So it's 188.4. I'm in radian mode. I'm in radian. No, I was in radian. So, so 3.282898 degrees. So radian is to degrees 3 point so I haven't put it in degrees, so I'm using a radian. So basically the radian is equivalent to 888.4 for 492 degrees. 492 degrees. 188.492 degrees. and this will give me the angle 188.492 degrees, and this will be enough for me to complete the pathway. So the area of the pathway is extend. So the pathway extends 188 units in degrees, but divided by 2 pi. Okay. So this is the angle in degrees. This is the pathway. No, no. No, wait, no, I'm not dumb. No, I'm not dumb. No, wrong, wrong, wrong. So this angle here is not complete. So I have to do times 2 pi r times 2 pi r. So I'll do divided by 180. If I divide by 180, it'll be in degrees. It will be in so that'll be in radian. So so the number will be so it's not radian yet. So I have to come so that pi divided by 180. Oh, times. So three. I'm doing now. I'm not doing 3.2898 the times pi. Times pi divided by 180, which will give me the angle in radians 0.057419. And now this radian can be times 2 pi r. So the radius is r, but the radius is 180. So the 180 is apart. So I'll do 2 times 2 times 2 times 180 will be 360 times 360 times 360 times 360. Okay, so it will be 180 plus 180. 180 times 2 will be 360. Yeah, so 180 times 2, so that'll be 180. So that'll be 360 times 360 times 2 times pi times 360 times 260 will be 20.86878 times pi was 2 pi r, and this will be 64 degrees in perimeter. So the perimeter will be 64 units in perimeter, or 64. Basically, I have the pathway now. So this will be two possibilities. You have so basically, I have to rotate 64 degrees, 64.939 with my initial input of between pi over 1 and pi over 3. Pi over 1 and pi over 3 to in angles 64.939 is the 939 or 934 is the rotation of the polar. So you get the polar rules. It gives you polar and so after that concludes the displacement. So basically this is the angle I have to take. Now to get displaced, I have to use the same formula, but I have to calculate the unit. So if I have so the first one is pathway. So let me continue. So the goal, what we're trying to do now is to have the pathway destroying from the pathway the shape and form. So the shape is a structure that I need to advance. So I have a 2-to-1 mapping of the keyboard. So the keyboards have to be 64.939 degrees rotation of my fingers of my hands, so I can input via kinematics and individual. So I can input anything that's in front of me. So if my hands are at the center of the keyboard, I have to rotate only 64.939 degrees. Any finger, any one of my fingers to get to the next key up. So you have to have a random sequence, and the random sequence is like if I move one right randomly, if I take two forward if I have two left walks, two left top, two lefts, 1 2 from Q to 1 2, 1 2. I should have a new random character, D, D, but D is not predetermined. So so if I have if I have if I have and then I shuffle A, and then I get I get if I shuffle A, I get B, I get B. B is not allowed. C is not allowed. D is allowed. But D is the worst case, the worst one I use. So I have to have A, D next to D, not A next to S. But I can shuffle the inverse way too. I have A, Z, Y, X. So I can have A, uh, A next to. I can have A next to Z and Y. I can have A next to X. But X is just one option I have. So because I have or I can rotate. So I can then have this option. I can rotate the lattice. So I can have A, uh, A, D, or X. But if I shift the axis again, I can have A next to D, and that will be random enough to shuffle. So you take the input character, things on the user access, and put it on the worst case on the left side. So you get so you get half of the alphabet. So you get 26 letters divided by 2, which would be uh, uh, 13, 13, 13. But 13 letters on the left, because people are left-handed. I'm left-handed. Left-handed is basically the easy stuff. So I can type my letters and have a phone call, any important thing on time of space at the same time. So the goal is to have every pathway work on polar axis. So the polar means you have you rotate, then you move, then you elevate means you. So this is XYZ coordinate system, but for keyboard modeling, because the keyboard is a threat when your life is in danger. So you have every polar axis, every pathway, every path shape you can take. The shape of the problem, the shape of the every pathway, every path shape or structure or substructure, all the same thing that should not that should indict a disjoint lattice. So you have disjoint lattices or disjoint dimension of access of freedom. The structure is a disjoint dexterity model. So it's a disjoint determining the freedom of your movement of hands. So you don't so you can type less. You have to take more time to type. But more time to type doesn't mean you can't make a call. You can do your navigation. So this framework works because you get the angle, but let's say you get displaced 36 how much is the finger? You get okay, 5 centimeter. 5 centimeter. This basically 10 centimeter. Now let's do 15 centimeter. So you get displaced 15 centimeters. So you have the angle again if 64.93 of your left hand rotation, and you get I get displaced 15 centimeters centimeters. Let's say 12.5 centimeters, 12.5 centimeters away from my human skin. You have to mathematically able to calculate that keyboard too. Mathematically to know what the key is, so you can indicate to the computer do some the key to the 5.5 centimeters away from 65 to 4.983 degrees has to be mathematically known. This is how to shuffle. So you have every two keyboards has to shuffle. So you have the left keyboard, you know where every key is, but it appears it is random. It's a random generator. So the 2-to-1 mapping is basically if I have two random inputs, two pathway, I have one. If I have two left, I have one right term. If I have two left, I have one right turn. If I have two ups, I have one down turn, one down movement. If I have one left, I have two right. If that's 1 to 2 happen, but it's basically to show randomness. You shuffle via the sequence, and the sequence is random because the number or the computational sequence allows you to determine the first. So you have 64.925 12.5 centimeters of displacement and elevation, which means how much your fingers press down on the keys, how much the keyboard elevates. The elevation is really important for vowels. So as a policy, we shall elevate all the vowels of Igbo philosophy. So A, E, I, O, U, the six vowels. We have six vowels in Igbo. They're tonal. We have tonal vowels. So we have six vowels and 34 consonants, I believe. So all the vowels should be elevated because they let you breathe. So the goal is to have the keyboard respect you. Every pathway, shape, or void, but it's a disjoint dexterity allows you to move freely without getting pressing the wrong keys. Disjoint dexterity model for pressing the right keys and sending the right messages to the trident axis and pointers. Thank you guys for watching. This video is now up. Let me just show you my work on the board. So the elevation will be the height. what will be the height? Base times height. The height will be so you get width times height. Base you get base times height, but the base times you get the base, which is basically you get the base, you get the width times the height, which is one base. So it's the baseline. So the base, okay, the base of the keyboard. But you get half of that. You get times two bases equals one height. And that's the elevation parameter. So the elevation is basically so you get half times base times height, half times width times height, or half times base, which will give you when the keyboard is down, keyboard down. Because the half times base means that it seems to have. If you have one full base, you have width times height squared, and that will be if the keyboard is up and it's elevated. So the elevation has to determine A, E, I, O, U, and the vowels and the 12 consonants that are most used frequently in Igbo philosophy. So okay, guys, peace, take care, love you guys. I got to have something done to me today, but I have a lot to do. Um, uh, uh, for now. Take this video and try to, if you can, Namdi, guys, try to complete the part, the shape, every pathway, shape and form, the form of the problem, form of the structure. Try to give the motivation. So the form will be, you get the structure, you get a structure which is data structure. I'm referring to that's heterogeneous, homogeneous, and you get the shape of the structure, which is substructure. So the shape is a substructure. And you have one more thing. You have the pathway, shape, and form. And the form of the problem, the formal disjoint form, I'm referring to of the geometry of the system via Laplace integrals. Alpha, if alpha, alpha Lima, if alpha, P for Papa, I for India, S for Sarah, which is my invention of Laplace calculus, which works in polar axis. Thank you.